In the theory videos, we have seen that there is a relationship between the energy that we consume and the emissions of CO2 that we emit to the atmosphere. In this video, we are going to see this relation directly by making some calculations that give you a real evidence that this is true. To this, we are going to use some of the data that we have seen. Here we have the amount of energy that we consume in the whole world, and we will take the one due to the transport, and we take this value, the value of the energy that more or less at 2020 we are using, that is more or less 1.2 multiplied by 10 to the 8 terajoules of energy. On the other side, we are going to compare with this other data that we have seen also, that is the amount of emissions due to the transport, that we also have more or less the value at 2020, that approximately is 9 gigatons of carbon dioxide. In order to make the relation, we will see a third value, that is the amount of energy that is giving me the gasoline. That is the most used fuel used in transport. We have seen that due to its properties is the more used energy source. And remember that gasoline is giving me 47 megajoules of energy for each kilogram that I'm burning of gasoline. Well, we need another piece of information, that is that when we burn fossil combustibles, we have also seen that carbon has mixed with oxygen, and also the hydrogen is mixing with the oxygen. So at the end, we are creating all these particles. And now what is considered in the emissions is just the carbon dioxide. In order to know the amount of carbon dioxide that we emit from burning fossil fuel, we have to think that each carbon that I have is converted in a carbon dioxide molecule. The mass, the atomic mass of carbon is 12 UMA, and the amount and the masses of the carbon dioxide is, the mass of carbon is 12 UMA, and the mass of oxygen is 16 UMA. So this means that this molecule, as it has 1 carbon and 2 oxygen, its weight is 44 UMA. This means that for each carbon that is generating a molecule of carbon dioxide, for each atom in 1 kilogram of gasoline, for example, we are going to generate 44 divided by 12, because this is the amount. So this is the increase in the mass that we are obtaining. That is more or less 3.7. This means that for each kilogram of gasoline, we will emit 3.7 kilograms of CO2. This is very important because we will need it to make our calculations. So now let's going to calculate the amount of energy, the amount of gasoline that I need to obtain this 1.2 10 to the 8 terajoules of energy. This is the energy that I'm using. This is 1.2 10 to the 8, 10 to the 12 joules of energy. and this means 1.2 10 to the 20 joules. The power, the heat of combustion of gasoline, it was 47.3 megajoules per kilogram. And if we pass it to joules, we get this value. So if we divide one by the other, the amount of mass that I need of gasoline is the energy divided by this value, and this is giving me 2.5 10 to the 12 kilogram. Now remember that each kilogram of gasoline is giving me 3.7 kilograms of CO2. So this means that the amount of CO2 is 2.5 10 to the 12 multiplied by 3.7. That is approximately 9.2 10 to the 12. That can be expressed by 10 to the 9, 10 to the 3 kilograms, and I do this because 1000 kilogram is 1 ton. So this is 9.3 to 10 to the 9 tons of CO2 that are 9.2 gigatons of CO2.